Hi students, once again I welcome you all to my channel Abrar Sir classes. Today we'll be seeing some interesting problems on the topic LR circuit of electromagnetic induction. This is the first problem. What it is saying, a solenoid has an inductance of 50 millihenry, okay, 50 millihenry and a resistance of 0.025 ohm. This is 50 millihenry and resistance of 0.025 ohm. If it is connected to a battery, okay, this is connected to a battery, okay, let us say its EMF is E. How long will it take for the current to reach one half of its final equilibrium? What it is saying? It is saying that if the current is I is equal to I naught by 2, I is equal to I naught by 2, T is equal to question mark. Okay, T is equal to question mark. He is asking how much is it. Now we have the formula for growth of current. I is equal to I naught into 1 minus e to the power of minus t by tau, where tau is what? Time constant, that is given by L by R. That is equal to, how much is L here? L is 50 millihenry. 50 into 10 to the power of minus 3 divided by R is how much? 0.025. Okay, tau. So tau is equal to how much? This is 50, means I can write the 50 by 25 is equal to 2 seconds. 2 seconds, right? And what about the value of tau? That is time constant is 2 seconds. Now what exactly you have to calculate? You have to calculate the value of t here. Okay, when I is equal to what? I naught by 2. Okay, that is equal to I naught into 1 minus e to the power of minus t by 2 I can write here. Okay, I naught gets cancelled. Here I can write this as 1 by 2 is equal to 1 minus e to the power of minus t by 2. So I can write this as e to the power of minus t by 2 is equal to 1 minus 1 by 2 is half. How to simplify this t here? I can take what? Log on both the sides. I can take log on both the sides. Therefore, minus t by 2 log of e to base e is equal to log of 1 by 2 to base e. Right? Okay. Now, what is log of e to base e? Log of e to base e is nothing but what? 1. Right? Log of e to base e is equal to 1. So I can write this as what? Minus t by 2. That is equal to, I can write this as what? Minus log of 2 to base e. To cancel this what? Minus minus. Okay. That is equal to, t is equal to 2 into log of 2 to base e. What is the value of log of what is the value of log of 2 to base e? That is equal to 0.69. 0.69. Therefore, t will be equal to, I can write this, t is equal to 2 into what? 0.69. That is equal to, t is equal to 1.38 seconds. Hope you have understood this very easy problem. Here it is based on only one formula, that is growth of current I is equal to I naught into 1 minus e to the power of minus t by tau, where tau is equal to what? This is called tau. Okay, tau is current. Tau is what? Tau is time constant. Okay, and I naught is the peak current. Tau is the what? The time constant. That is given by L by R. Tau is equal to 2 seconds we got. And then here, if I is equal to I naught by 2, simplify for t, you are getting 1.38 seconds is the right answer. We'll see the next problem. What is saying, in the circuit shown, how soon will the coil current reach eta? Okay, this is called eta on fraction, that is less than 1. Okay, fraction. Okay, this is the fraction they have given, that is less than 1, okay, of the steady state value. What they are asking, one inductor they have given here, one resistor is there here, and it is connected to what? A constant voltage source. Okay, it is connected to what? Constant voltage source. Constant voltage source. Right. Constant voltage source. Okay, this is R, this is L. Let us say constant voltage source is V. Okay, what they are telling in this circuit shown, how soon will the coil current reach eta fraction? Eta fraction means I is equal to what? If the current is flowing like this, because this is plus and this is minus. Okay, I is equal to eta I naught. Okay, I is equal to eta I naught. Now you have the formula for growth of current. I is equal to what? I naught into 1 minus e to the power of minus t by tau. Okay, now I is nothing but what? Eta I naught, that is equal to I naught into 1 minus e to the power of minus t by tau. Okay, where we know tau is equal to what? L by R, that is time constant. Now here I naught gets cancelled. I naught gets cancelled. I'll be getting, if I simplify, eta is equal to 1 minus e to the power of minus t by tau. So here I can simplify for e to the power of minus t by tau. I'm going to get what? 1 minus of eta. Okay, 1 minus of eta. Now I can take log on both sides, minus t by tau. Okay, minus t by tau, minus t by tau, log of e to base e, because this power will get multiplied here, that is equal to log of base e into what? Log of 1 minus eta to base e. Right. Now what is log of e to base e is 1. I can write this as what? Minus t by tau, that is equal to what? Because log of e to base e is what? This is 1. I can write this as what? Log of 1 minus eta to base e. Now I can simplify this to minus t by tau. I can write this as what? Minus of log of 1 divided by 1 minus eta, just to cancel this minus. Therefore I can write this as what? T is equal to tau into log of 1 divided by 1 minus eta to base e. That is nothing but what? What is tau? I have told you what is tau is nothing but what? L by R. So L by R, I can write this as what? Ln. Okay, natural logarithm. Ln of what? 1 divided by 1 minus of eta. L by R, log of what? That is log of base e is nothing but what? Log of base e is nothing but ln. Okay, I can write this is the correct answer. L by R, ln of 1 divided by 1 minus eta is the right answer. Hope you understood this sum. We will go to the next problem. What it is saying, in the circuit shown in the figure, E they have given how many volts? 10 volts. Okay, R1 is how much? 1 ohm. R2 is how much? 2 ohm. R3 is 3 ohm. Right. L is given. L is equal to how much? L is here 2 Henry they have given. Calculate the value of current I1 and I2 immediately after key is closed. When key is closed, okay, I'll just write on this one circuit. When key is closed, this is E. When this key is closed, what happens to the inductor? It gets open circuit. At t is equal to 0, okay, at t is equal to 0, when the switch is closed, when the key S is closed, this is S. Okay, this is yes. When the key S is closed, they are saying. Okay, this S is what? Closed. Closed. At t is equal to 0, when this switch is closed, what happens? L is what? Open circuit. This is open circuit. R3, how many ohms? R3 is 3 ohm. This is 2 ohm, and this is 1 ohm. This is 1 ohm. No current flows here. Okay, only one current will flowing. This is I1. Okay, this is I1 they have given. This is what? I2 they have given, and this is what? I3. Okay, I3 will be 0 because it is open circuited. Okay, I3 is 0. I1 is equal to I2. I1 is equal to I2 plus minus 10 volts. E is equal to how many volts? 10 volts. Okay, this is what? R1 is how many ohm? 1 ohm. R2 is how many ohm? 2 ohm. This is R3. This is R3, and this is R2. Okay, this is R2. R2 is 2 ohm. What is the value of current? I1 is equal to what? I2, because same current is flowing here. I1 is equal to I2 is equal to E divided by what? E divided by R1 plus of R2. No current is flowing in R3 here. Okay, I3 is 0. I3 is 0 here. Directly I can write I3 is equal to 0. I1 is equal to I2. How much is E? 10 divided by these two RNCs 1 plus how much? 1 plus 2. 1 plus 2 that is equal to 10 by 3 is equal to how much? 3.33. 3.3 amperes I can write. 3.3. And here it is 0 ampere. So I1 is equal to I2. 3.3, 3.3, 0. This is the correct answer. Hope you understood this one. Okay, 3.3 ampere, 3.3 ampere and 0 ampere. This is I1. Okay, this is I2. And this is what? This is I3. B is the right answer. Hope you understood this sum. Next problem. The switches in figure A and B. This is figure A. Okay. And this is what? Figure B. This is figure A and this is figure B. What they are telling in figure A and B. What happens? Okay. T is equal to 0 are closed. This is closed. This is closed at T is equal to 0. Okay. When this is closed, what happens? What happened when T is equal to 0? When T is equal to 0, what is the equation of Q? We know that Q is equal to what? Q naught into 1 minus e to the power of minus T by tau. Okay. At T is equal to 0, what happens? Q is equal to Q naught into 1 minus e to the power of minus of 0. Okay. Correct. What is e to the power of 0 is 1. This gets cancelled. Okay. Everything will be 0 here. Q is equal to 0. Q is equal to 0. At T is equal to infinity. Okay. This is at T is equal to 0 when the switch is closed. That is after a long time. After a long time, when at T is equal to infinity, what happens? Q is equal to Q naught into 1 minus e to the power of minus infinity. What is e to the power of minus infinity? This is 0. Okay, this is 0, and Q will be equal to what? Q naught. That is maximum. Q is equal to Q naught. Okay, Q is equal to 0 at T is equal to 0. At T is equal to 0, Q is equal to 0. That is after a long time when T is equal to infinity, what will be Q? Q will be equal to Q naught, and Q naught is equal to what? C into E. C into E. Now in case of, this is in case of C. In case of CR circuit. In case of what? CR circuit. Now what happens in case of LR circuit? In case of LR circuit, okay, we have to write the equation of current. Okay, I is equal to what? I naught into 1 minus e to the power of minus T by tau. Okay, immediately after the switch is closed, if this switch is closed, at T is equal to 0, this switch is closed, let us say. At T is equal to 0, what happens? At T is equal to 0, I is equal to I naught into 1 minus e to the power of minus 0. Okay, so this whole thing will be 0. I will be equal to 0. At t is equal to 0, I is equal to 0. That is after a long time at t is equal to infinity, what happens? I will be equal to, just substitute t as infinity here, I is equal to I naught into 1 minus e to the power of minus infinity. That is 0. Okay. Therefore, I will be what? Equal to I naught, and that is given by what? I is equal to I naught, that is given by E by R. That is equal to E by R. This Q is equal to Q naught, that is equal to C into E here, and this is E by R. Okay, E by R. Now we will see the answers here. The charge on C just at t is equal to 0 is at t is equal to 0, Q is equal to 0. This is wrong. Okay, the charge on C long after t is equal to 0. Long after means t is equal to infinity. Okay, at t is equal to infinity, it is given by C into E. This is the right answer. Okay, the current in L just before t is equal to T naught is E by R. Is E by R. No, this is wrong. Okay, at t is equal to 0, I is equal to 0, and the current in L long after t is equal to T naught is E by R. Okay, this is right answer. This is the right answer, and here this is the right answer. Okay, B and D are true here. B and D are true here. Hope you have understood this. Understood? The first answer is the charge on C long after t is equal to 0 is E by C. The current in L long after t is equal to T naught is E by R is the right answer. Hope you understood this. We'll see the next problem. What it is saying in the circuit shown below, what will be the reading of the ammeter just after closing the switch? Okay, once if the switch is closed at t is equal to 0, what happens? What is the reading of the ammeter if this is closed? If this is, let us say, this is a key. Okay, if it is closed, what happens? This resistor will be as it is. This resistor will be as it is. This gets open circuited. L is what? Open circuit. L is open circuit. Therefore, this is 5 ohm. This is 5 ohm. This is 5 ohm. This is plus. This is minus 10 volts. Okay, no current flows here. No current flows here. Give it. Okay, I is equal to what? I is nothing but V by R. 10 by 5 plus 5. Okay, 5 plus 5. Okay, these two are in series. 10 by 10 is equal to how many ampere? That is 1 ampere is the right answer. Hope you have understood this one. We will see the next problem. If any next problem is there, yeah. Now in the circuit, this is at t is equal to, this is the circuit at t is equal to 0. Okay, just after closing the switch at t is equal to 0. At t is equal to 0. Okay, just after closing the switch. Now here in the next problem, what is saying? Reading of the ammeter long after closing the switch at t is equal to infinity. At t is equal to infinity, what happens? At t is equal to infinity, what happens? The inductor behaves like a what? Short circuit. At t is equal to infinity, L behaves like a what? Short circuit. Okay, this is 5 ohm, this is 5 ohm, and this is 5 ohm, and this is plus minus what? 10. Okay, now this is plus minus 10 volts. This is 5 ohm. This is 5 in parallel with 5 is 2.5 ohm. What is I is equal to? I is equal to V by R. Okay, I is equal to V by R. 10 divided by 7.5. 10 divided by 15 by 2 I can write. I can write this as 10 into 2 by 15. 3 5s are 15. 2 5s are 10. 4 by 3 amperes. 4 by 3 amperes right answer. Hope you understood this. At t is equal to infinity, okay, L will act as short circuit. At t is equal to 0, L will be what? L will be open circuited. L will be what? Open circuited. L is open circuit. Okay. At t is equal to infinity, at t is equal to L is what? L will be what? always short circuited. L will be short circuited. Short circuit. Hope you understood this one. You see the next problem. What is saying? It is saying figure shows circuit that contains three identical resistors. Again, the same thing. Okay, just see the current I through the battery just after the switch is closed. If the switch is closed, what happened? If the switch is closed, this will be what? Open circuited. Okay, this will be what? Open circuited. If this is open circuited, okay, this is open circuited. L is what? Open circuited. Open circuit. Okay, open circuit, no current flows here. And this is what? Open circuit. This is what? Open circuit. And this is what? Short circuited. This is what? C is what? Short circuited. Now how the circuit looks? It is like this. R, this is R. This is plus minus E. Okay, remember for C, okay, for C at T is equal to 0, okay, this C behaves like a what? Short circuit. C behaves like a short circuit. At T is equal to infinity, this is ulta of what? Inductor. Okay, at T infinity, this is a open circuit. This is for C, I am writing for capacitor. Okay, now just see here how to calculate the value of I. Okay, these two are in C. This is short circuit, means again I can write like this. This, don't consider this one. R in parallel with R, like this. R in parallel with what? R, because this is short circuited. Okay, R, this is E. Understood? How to calculate I? I is equal to what? This is R by 2. R by 2, this is E. How to calculate I? I will be equal to what? I will be equal to E divided by R by 2. How much is E they have given? E they have given as how many volts? 18 volts. 18 volts. And R they have given 9 by 2. That is 18 into 2 by 9. 2 times, yes, 4 amperes. 4 amperes is the right answer. Hope you understood this one. Okay, this is C is what? Short circuit. Now next problem we'll see. Again the same problem. Okay, here C is not there. In parallel with L, directly L is there. Open circuited. Okay, open circuit at T is equal to 0. Okay, write the circuit diagram. Open circuit. This is also open circuit. Okay, so don't consider this one. This is open circuit. Okay, this is also open circuit. Now you'll be having only one. If this is closed, you'll be having only one resistor like this. Okay, this also you have to not consider, because this is what? Open circuit, no current flows here. Okay, this is plus minus E R. Okay, how much is the value of I? How much current? I is equal to E by R. How much is E? That is 18 volts by R is how much? R is 9 ohm. That is equal to 2 amperes. I is equal to 2 amperes. Hope you understood this. Okay, you might have enjoyed these problems on the topic LR circuit of electromagnetic induction chapter. If you like this video, kindly like it, share with your friends, subscribe for my channel, and ask doubts in the comment box. Thank you one and all. I wish you all the best for your KCET and NEET exams.